Hi, welcome to my video on graph a log function. F of x equals negative log of x plus 1 to the base of a half plus 4. I made up a different equation instead of the bases being integers. I wanted a fraction. So we want to graph this f of x as it's a log function. I want to state its domain, range, and asymptote. And because it's a log function, then we know, or should know, that the asymptote is going to be a vertical line. But let's start. We want the f of x, and we'll do the basic equation for log. The basic equation, the base is a half, and we'll have an x. So this graph, the f of x is a y, so it's y equals log x base of a half. And this equation becomes a half base exponent number. So notice the log equation, the y is in the exponent. So if that be the case, what I like to do, because y is in the exponent, is fill in the values of y as -2, -1, 0, 1, 2. Because if we had an exponential, we'd be filling these values in for x. Now, because it's the reflection of the graph of the exponential in the line y equals x, we'll fill in the -2 to 2 for the y's. So when we take a half and put in a -2, a half to the -2, let's do it here, half to the -2, becomes 2. The negative flips the fraction around to be 2, so 2 squared gives me a 4. Then we have a half to the -1. Again, the negative flips the half around to be 2 over 1 or 2. 2 to the 1 is 2. And y is 0, half to the 0 is 1. And we have y is 1, half to the 1 is a half. We have a 2 for y. A half squared is a half times a half, which is 1/4. This is the basic, because we can graph this as using the mapping rule. So let's look at this equation. F of x, we make it y negative log of 1/2 x plus 1 add on 4. So what we have this equation. So the mapping rule based on this, so both of them are in terms of y. So the mapping rule is x comma y. Let's map to. And let's see. So the x, this is x plus 1. So this is an x minus 1. And the y is the negative of the log. So it's a negative y plus 4. The only difference is this is the log of this expression here. So this is the negative y plus 4. So when we take these table of values and sub them into here, we will get the graph of this log function. So we're going to put x is 4 in. 4 minus 1 is a 3. We're going to put a 2 in. 2 minus 1 is 1. We're going to put a 1 in. 1 minus 1 is a 0. We're going to put a half in. Half minus 1 is a negative a half. We're going to put a 1/4 in for x. 1/4 minus 1 is negative 3/4. And now we'll sub these values in for y. So y is -2. So the negative of a -2 is 2. 2 plus 2 is, 2 plus 4 is 6. We're going to put a -1 in. The negative of a -1 is 1. 1 plus 4 is 5. We put a 0 in. The negative of 0 is 0. 0 plus 4 is 4. Put a 1 in. 1. So the negative of 1 is -1 plus 4 is a 3. And you notice these are going down by 1, so this one should be a 2. Let's put a 2 in. The negative of 2 is -2 plus 4 is 2. So this is the table of values that we have. And we also want to know, if you look at it closely, that x plus 1 is the number. This is the base, that's the exponent, that's the number. X plus 1 got to be greater than 0. That means that the x has got to be greater than negative 1. And the asymptote, if you think about it, ASY, for asymptote is x equals negative 1. The asymptote is when you make this expression equal to 0. So, here we go. When x is 3, y is 6. When x is 1, y is 5. When x is 1, y is 5. When x is 0, y is 4. X is 0, y is 4. When x is a negative a half, y is 3. X is a negative a half, y is 3. When x is a negative 3/4, y is 2. Negative 3/4, y is 2. So you can see, now we said the asymptote was x equals negative 1. So if we put a dotted line down here like this, there's the asymptote. This is x equals negative 1. So the graph is working like this, comes down, and it gets closer and closer and closer, but it never touches. So notice this is getting, that's a negative a half, negative 3/4, and we did it again with 1 plugged in. Then we get this one to be probably negative 7/8, but you can check that out. And your domain, the domain is the x's, so the domain is x is greater than negative 1. Set of all x is greater than 1, x belongs to the real numbers. So all x is greater than negative 1. The range is a set of all y's, so that y belongs to the reals. All values of y will fit into, notice this equation here, any value of y will fit in to this base of a half, or any value of y will fit in here if you change this one to a log form in looking like this. And the asymptote is x equals negative 1. Another way to think about this, if you didn't want to do the basic graph, like put these table of values in and do the mapping rule as is, would be to look at this equation and pick out your numbers that will give you a base of 2. So if you put a 0 here, you get a 1. So a half to what power of a half will give you a 1? It would have been a 0. So this is a 0, so you get negative of 0 is a 4, but that's a little bit more complicated. So 0 plugged in for x will give you 4. If you put a 1 in here, a 1 plus 1 gives you a 2. So what power of a half gives you a 2, and it's a negative 1. And so this is a negative 1. So the negative of a negative 1 is 1, and 1 plus 4 will give you 5. You can go that way. You can put the values of x in and work this out for y. Again, looking at it, the basic equation like this, doing the table of values, and then do the mapping rule. Or again, plug the values of x in first and pick up the value of y. But these values of x have to have a base of 2, like 0, 2, 4, 8, a half, a quarter, etc. Anyway, just a graphing a log function, and a log function again has an asymptote of x equals, so it's x equals whatever this number is, gives you 0. And that brings us to the end of this video. If you like my video, click on the like button, click on the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.